My name's Rochelle Longval, and I'm the Vice President of Geothermal at BlueSpark Energy. And at BlueSpark, we inspire energetic change. So we take a small amount of electricity at the surface, and we convert that to a high power event downhole. So this is high power electro-hydraulic pulses. And through doing this, we're able to break up material flow impediments in the near wellbore region. So for geothermal, we're talking about scale. For our method, electro-hydraulic pulse, compared to chemical and mechanical, we are an eco-friendly solution that's safe, and we're able to maintain the wellbore integrity. This is really critical when compared to chemical and mechanical treatments. So we're able to ensure that we're not damaging the reservoir and we're not damaging the completion equipment. There's been 39 types of scale treated to date, which is really critical. There's a targeted approach, and it is rigless, so it can be run on wireline. In regards to wellbore integrity, this is something that is really critically important for the BlueSpark technology. We have 1,000 joules of energy that we're entering at the surface. So this is the same amount of energy that goes into making your morning cup of coffee. When we put this down the wellbore, we create high power. That's how we get our blue spark. Now that high power event, that's like creating the lightning. But what's actually propagating in your wellbore is the thunder. When that thunder propagates, it's still at that 1,000 joules of energy, so that small amount of energy. We're unable to affect the wellbore integrity because when we look at the cement behind your casing, we're gonna have 94% of our shock waves are gonna reflect back from that steel, and they're not gonna be coming into contact with your cement. So this is really critical. And the 1.5% that does end up getting absorbed down the line by your cement is going to be a really small amount of energy. So once again, the 1,000 joules. As a result, looking at cement bond logs and also doing our demonstrations as well as our proven results, we can see that that cement stays intact as well as our steel casing. When it comes to deploying our technology, it's very simple. We can be deployed on wireline, and we work with over 99% of wireline companies. So a recent project that we had was the Lakeview project in Oregon. And this one was really special to us because they actually had to shut down one of their schools due to a lack of a high enough flow rate with scale buildup. And so BlueSpark was brought in to help them as that technology that could provide that well integrity, but also being in a rural community without drilling rigs nearby. This was an excellent way to deploy this tool. Within 8 hours, we were able to take their 88 gallons per minute and bring it up to 206 gallons per minute. They needed 130. With this, we were able to heat up the school once again. We're actually gonna go and see a real live demo of the electro-hydraulic pulse in action.
Quite adaptable to the logging cable heads they use today, or the coil tubing logging cable heads they use today. We take that small trickle of energy, low voltage, low current, we amplify that, and we store it in about 7.5 meters of capacitors. The capacitors do two things. They store energy at a very high potential, 30,000 volts, but more importantly, they release that energy in millionths of a second. 5 millionths of a second they release that. What happens here then, we jump across the spark gap. So same as an old school car that had a spark gap. You tune that gap for performance, same thing we do here. When that plasma jumps across from that anode to cathode, it superheats the water, turns it into a gas. That creates that volumetric expansion, and that propagates the hydraulic wave. The pressure front of that wave is 10 to 12,000 psi. It then has a compressional moment on your geomaterials. When the gas bubble collapses, it has a tensile moment. So that push-pull effect breaks down those brittle materials, delaminates them. That's what we're going to show you. I'm going to pulse now because everyone's been patiently waiting for us to get set up. We're here for more questions as they go. One thing I want you to realize is your cell phone today that you're holding in your hand or in your pocket, the power of the demonstration. We're going to use maybe 12,000 joules. It's going to be loud, less than 85 decibels. So some people might jump, but it's not going to hurt. That's geothermal water, so it's okay coming out the top. So I'll pull the target out, and you can see the holes we've opened up. For our operation in a well, we do a pulse density. We match the number of pulses to the problem we're trying to solve, the completion as well. So we'll do typically for a silica scale, we'll do 200 pulses per meter. That takes us about 17 minutes to treat. We can selectively treat that zone. We can treat a meter low, a meter high based on where your most permeable zones are. We can selectively treat, and we can't treat outside of where we're pulsing. There's no ability for us to do that. As the wave again travels through that completion, it loses energy quite rapidly. So our vertical resolution of the pulse is less than a meter in length. So we can see we've opened up that half-inch perforation. The last thing that we point out, for those that have sensitive completions, like you've got cement you don't want impacted, if we pulse in the wrong spot, we can't damage the cement behind pipe. You can see here, the cement that's behind the steel acts as almost a perfect reflector. 88 to 94% of the energy gets reflected by that steel. Just makes noises out to completion. We've done upwards of 12 geothermal jobs today, Japan, Philippines, and the US. And we are now looking to get into the Iceland geothermal market with a unique technology. We bring zero risk to the well site. No explosives, no chemical, no radiation. We make a pressure moment at the surface. We really bring a benign tool. Worst case scenario, we like to say we do nothing downhole. But where there's scale, we have a solution.